Yeah? You can all hear me fine?
Yep.
Very good. All right. So, I want to talk a little bit about Active Directory today. I also want to talk a little bit about PowerShell because this is a PowerShell event. First things first. My name is Mathias. I work as a security administrator at a company called Booking.com. You may have heard of it. Most of my day-to-day job entails going around talking to people, talking some more, finding some other people, talking to them, figuring out what kind of attack vectors and vulnerabilities both our corporate and our production networks might be susceptible to, and what we can kind of do to both mitigate those and monitor our way out of them. I also work closely with our internal IT support organization around manageability and security of kind of our corporate infrastructure. In my spare time, I spend a lot of time on Stack Exchange, answering questions that people may have, usually about PowerShell, but also any other kind of Microsoft infrastructure-related questions. I used to be an Active Directory administrator full-time. I used to work with one of the largest service provider companies in the world, managing their global Active Directory infrastructure of some 100 domain controllers across, I think, 80 or 90 locations across the globe. And when I walk around at Booking.com talking to people about all these interesting topics, all these attackers and hackers who are out to get us, sometimes I start to reminisce a little bit, and I just want to get my hands dirty and start working with Active Directory. So let's talk a little bit about that. Why do I want to talk about Active Directory? We've heard a lot today about kind of convergence towards the cloud. We're all kind of moving that direction. That doesn't change the fact that Active Directory is still an integral part of many organizations in terms of their IT footprint. Even if you move either your line of business applications or other parts of your production to the cloud, Active Directory still kind of serves as a basis for identity and access management for a lot of companies. How many in here either work with Active Directory, rely on Active Directory, or have worked with it recently? So quite a sizable portion. A lot of types of applications depend on a responsive directory service. Many people think, okay, we have a bunch of users, they have a Windows computer, they need to be able to log in, they need to be able to type their password and get a response like fairly quickly. That's not the only thing, right? Directories are classically used for looking up information like telephone numbers. That's kind of where the idea of having a digital directory came from in the first place. And today we have a myriad of different business applications that rely on Active Directory either for storage of application or storage of data, or rely on some of the kind of IAM related data that's already in there. Even though it's used by a lot of people and touched by a lot of applications, my impression when I go out and talk to people about Active Directory is that it's kind of poorly understood. It's a very complicated product, right? It has a lot of layers. This weird multi-master replication structure, and it's simply impossible to know everything about it, right? I used to work full-time with Active Directory for almost 5 years. I wouldn't pretend to know 10% about what there is to know about Active Directory domain services. And that also means that it's usually underutilized, right? If you don't understand what you're using with, how are you going to get the most out of it? It also happens to be a personal favorite of mine. It's just a great geek topic, right? There are so many moving parts, there are so many things to understand. So, geeking out over Active Directory is great, right? The last thing is that the concepts around Active Directory and Active Directory data storage are generally transferable to other means of data store, right? So even though you might not be able to kind of understand the database intrinsics of Active Directory and transfer that directly onto SQL Server or Hadoop or something like that, the idea that thinking about how your data is structured from the disk in memory into your applications, that kind of thinking is transferable no matter what kind of data store you use and what kind of data you're using, right? But now that I have your attention, let's talk about something else. This, what's going on in there? a lot, hopefully. I used to have a really hard time doing these things, speaking in public, speaking to people about technical stuff that I love in the first place. And earlier this summer, I got whirled into a conversation on Twitter about presenting live and about doing live coding. So sitting down on Twitch or a platform like that, doing some coding exercises, trying to implement some solutions, while people in real time can kind of respond. There's a syntax error over there. You did some logic flaws, and my argument was kind of that my vanity didn't really permit me to do that kind of thing live, right? And then I got an interesting response. I got this response. Someone said, it doesn't matter, right? Like, don't let your vanity stand in the way. And he said, exactly. And he said something interesting. People watch to learn tools, thought process, and tech. And people don't really care if things don't work out in the end, right? They want to be part of the journey. They want to figure out how you're thinking about these things and how you kind of came to the conclusion that, OK, I want to solve a certain problem in a certain way. So in the interest of that, and I completely agree with this, right? So in the interest of that, I'm trying to kind of work myself back 5-6 years and try to figure out what the hell was going on in the head of this young man when he set out to learn Active Directory. All right, so back on topic. A little bit on PowerShell performance optimization in general. It's kind of a favorite PowerShell topic of mine. In very simplified terms, we can think about the act of kind of getting our code to run either faster or more efficient on kind of two axes. How much memory do we need to consume while we process our data, while we run our code, and how much time does it take? Time can mean two things here. How much CPU time are you actually using? How much energy do you need to feed into this operation? But also, how much real time does it take, right? If you have some time-sensitive operation or something that you need to repeat every 10, 15, 5 minutes, then it's maybe not that good if it runs for half an hour every time. Generally, you would hope, right, that you could kind of maybe land somewhere along this diagonal, right? Either we're utilizing a lot of memory, maybe we have a big box with a lot of RAM, we can use that freely, and then by kind of spreading our data or processing out over a lot of memory, maybe we can get some gains on time, both CPU and real time. Otherwise, sometimes it has to go really fast, really snappy. Throw some more RAM at the box, and it's fine, right? The other way around, if you have something that's not really time sensitive, but you don't want to invest in a lot of hardware, then one maybe think about moving to the cloud and let someone else take care of that. But otherwise, see if you can kind of optimize for long running but not very memory intensive tasks. So people, they venture into this, they venture into automation, they venture into coding, usually with not much of a programming background, and they end up here. Right? It takes a long time, it consumes a lot of memory, and then maybe you get some results in the end if your machine didn't crash. Obviously, we kind of want to move in this direction, away from this quadrant up here, but it's not always possible, right? There's a bunch of trade-offs. And in order to kind of understand what these trade-offs are, when you look at it this way, it may become kind of obvious, right? If you look at a single machine without considering the network, at the very lowest level, you have some hardware, some specialized hardware like a CPU, for example, that does its job really, really fast, do millions of cycles in a second, right? Then we have a bunch of layers of abstraction that allow us to do things with programming languages that are almost, human languages, right? So you have something like a hardware abstraction layer on top of your hardware that can be programmed. In Windows, you have a bunch of some maybe 20 years old APIs that were written for systems that were heavily memory constrained and therefore had to be optimized heavily. On top of that, you have application frameworks like .NET, where, okay, we take kind of another trade-off. We need a little more memory to spin up the runtime. We're going to use some more CPU cycles to do the same thing that we could have done down here. But we get some added abstractions that, again, kind of allow us to do something that's humanly readable once we dig into code, for example. In terms of PowerShell, we add some further layers of abstraction in order to make it easy to use and make it easy and kind of fast to prototype things. We have a bunch of built-in syntax in PowerShell, like operators, dash EQ, dash contains, dash split. We have a bunch of language statements, such as loop constructs and so on. And all of these things, including a lot of the command lists that come with PowerShell, are implemented in C#, right? So this is code that's written by a developer. It gets compiled, and it usually runs a little faster because the parser doesn't need to interpret it. The runtime doesn't need to figure out how to run this thing. And then at the very highest level, utilizing all of these things, we have scripts, right? People sit down and write using the PowerShell language. The further up the stack, this inverse pyramid of slowness, the slower it gets, right? The overhead is higher. Okay. Back to Active Directory. Active Directory is hosted on something called a domain controller. We all kind of know this, right? There's a bunch of servers standing in the data center. They all host a database or a copy of a database, and they all run something called a directory service agent. That's where it says DSA right up here. On top of this directory service agent, we have a bunch of built-in interfaces with which we can communicate with the directory, right, with the domain controller. LDAP being kind of the most prime example. We have a replication interface that the directory servers use to replicate data between them. MAPI, originally designed for kind of close exchange integration. And then SAM for authentication and authorization operations, right? On the left up here, network clients, right? We have a bunch of clients. They may be running some applications. It may be your computer trying to process some data, trying to run some reports. And you want to talk to one of these interfaces to get to the data in the domain controller. What we're going to focus on today, because for a lot of both application and reporting purposes, this is the de facto interface we're talking to, is LDAP, right? The lightweight directory access protocol. So another way of looking at this interaction with LDAP, if we kind of split every transaction or every search we do, it originates at the client, right? In my client application, I specify some search term that describes the data that I want to get back from the directory. I send that through a bunch of layers of abstraction on my own machine. It comes over to the domain controller. The directory service agent takes this query, unpacks it, looks at it, and then tries to find kind of the data in the directory or in the database that satisfies this query, right? And already here we see that it's a little more complex than the model we were looking at before, where we have a local computer where we can kind of, we have this pyramid, right? Now there's a bunch of other moving parts. Back to one of the first slides about kind of figuring out what the balance between, let's say, memory pressure and time pressure is. In this kind of interaction, like any other server-client application, we want to kind of try to find a balance between how much work can we offload to the domain controller versus how much work do we want to take on client side? That's a question.
It's maybe going too deep, too fast, but how do I know what I'm offloading to the domain controller? Because I could write through competence or incompetence a good or bad query.
Yes, that's a very good question. And I think, feel free to ask again later, but we're going to go through some examples diving into how we can kind of figure out, are we being incompetent or is the directory being incompetent? So I think we're going to touch on that. On the right-hand side here, how LDAP kind of maps onto the OSI model, it's not very different from any other application level protocol like HTTP, right? We also have a bunch of layers of abstraction like we would have in any other server client protocol.
Second question.
Yes?
In the days before we got the AD commandlets in PowerShell,
yes,
you could write native LDAP queries.
Yes.
In your layer, is either of those more efficient?
Yes and no. The Active Directory module, so the question was, before the Active Directory module kind of came along, we had a bunch of type accelerators in PowerShell, right, for directory entries and directory searchers. Yeah. And the question was, is that more efficient or, right, okay. So depending on how you use them, it may be more efficient.
Query for query. So do I rewrite my old code that used the old, what you called what they were, the LDAP
right.
data types, right? do I rewrite it into the now commandlets, or are they basically the same?
I think you're going to find that the performance trade-off is negligible.
Right.
If you're using LDAP queries using some of the type accelerators that were there already in PowerShell 2, and then try to port that to the Active Directory module. If you're using it correctly, you'll find that there's not really a trade-off, other than the next developer who comes along might be have a better chance of actually reading your code, right?
Yeah. Thank you very much.
Yeah. All right. So usually when I go out and talk about performance optimization in PowerShell, it's kind of the same topics that come up again and again, right? People kind of make the same mistakes because they don't know better. And so I thought maybe we'd try to write some just terrible PowerShell and see what that might look like. So if I can duplicate the screen. So this is an overly simple Active Directory setup. I only have a single domain controller. This would never happen in a production environment because, redundancy. Also, I have a bunch of user objects in here, but I don't have a ton of heavy application integrations. There's no Exchange organization or anything like that in there. What I do have in this directory is I run a call center. I have a bunch of call center agents. They all have a telephone number. So when I get an incoming call somewhere else in the business, I want to be able to maybe, let's say, resolve which agent is actually calling me, right? So the directory seems to be the perfect kind of data store for this kind of information, right? So what I usually see when people come asking for help about Active Directory performance is they do something like this, right? Can anyone tell me what 5 things are wrong with this? Okay, so we have the option to filter kind of server side, right, as we get the data, but we choose not to. Okay, that's one. Anything else?
Starting the beginning of agent would be horrible.
No paging.
Okay, so we're not really taking paging into account here. The Active Directory module itself takes care of it. So one of the things it does is it issues its query to the DSA, right, to the domain controller. The domain controller sends a client-side control back saying, "I've given you this much of the result. This is how much is left," and the Active Directory module internally figures out to use that cursor to then fetch the rest of the result. Okay, so get ID user, filter nothing, and then we actually kind of filter on the client side, right? So basically what we're telling the domain controller is, give me all the data you have, and then once you get it over in your own table, you kind of slice off 10% and then rest with away with the rest, right? So something like this would maybe be better off, let's say, create the filter. This. Now we don't need to waste CPU cycles on our client anymore, filtering this huge data set that we just brought over. But even better, we don't even need to bring it over the pipes in the first place, right? It can kind of stay where it needs to be. Okay, so I have a friend who was really big on reporting. He needs to figure out whether the data we have in Active Directory corresponds perfectly with the data he has in SAP or some other HR database, right? So he wants to make sure that at any one point in time, all of these agents have their correct manager assigned to them. So he does something like this. Okay, give me all the agents. I don't need the title anymore. Okay, for each of these agents, let me just get that manager attribute again. Right. Yeah. So, and then if we find the manager, let's just make sure we also get that right. And then down here, maybe we need to output this to Exchange. So let's maybe create a new object. Should leave it as is. Manager object here. Then maybe let's use this fancy commandlet right here to. I think we need a node property. Let's say. Name employee, value as the original user, right? We want to get, let's just say their name, and then let's just do this again, just to get that. Manager. All right.
You want to change line 9? You want to change the minus name?
Yes, absolutely, absolutely. Thank you very much. All right, so now we have our fancy reporting script here. Let's test it out. Okay, I don't know if anyone saw the first slide. I'm a terribly impatient person. I simply cannot wait for this, right?
You need a better domain controller.
Yeah, I need a better domain controller. If only I could move closer to the domain controller than using the domain controller as a client. Yes, Ian. Huh? Yeah. I need fewer employees, right? This must be the issue. Okay, so we kind of fixed the initial query, getting all the call center agents, right? But is this really necessary? I don't think so. Since we already have the object, right? We already kind of had the opportunity to request the manager property in the first place. Now, depending on how many agents I have or how many agents I employ or hire over the next couple of years, okay, so maybe this is a little faster now. Maybe we can get some results.
Don't you need to get the name back as well in the properties?
So the name is part of the default property set that comes back for users. So we don't need to worry about that. Okay, it's still terribly slow. Okay. Now, there are two kind of great mistakes I've made up here. One may be obvious if you've kind of been into this topic before, and that is this one. Add member is terribly slow because you take the object itself, you pipe it through the pipeline, you need to bind it to add member, then add member needs to inspect this object to figure out whether this property already exists in the first place. Once it's done that, it needs to do a bunch of, in the runtime, very expensive operations to kind of tack on some new properties onto this object. So this is going to be terribly slow. Okay, two kind of common solutions to this. This is going to work in PowerShell 2 and up. Using the dash property parameter with new object. This doesn't just work with P as object. You can use that to initialize values in any kind of new object as you invoke their constructor. But this is basically a hash table, right? So we just say employee, and the value is the name, and the same down here. So manager is the name of the manager. Okay, then at least the object creation down here is going to be somewhat faster. But there's still something we can do here. If we start thinking about what this relationship looks like between a manager and his employees, it's always a one-to-many relationship, right? It's not very often that you have an entire reporting chain where you just have one person on each level, right? The further you go down, the more people you have kind of indirectly managed by the layer above. And so that means that if I have, I think I have 25,000 call center agents in the directory right now, that means that I'm going to do an additional 25,000 lookups against the directory, one for each one. The likelihood of me retrieving 25,000 distinct managers is fairly low, right? Otherwise, we have really inefficient management in this company, right? So what can we do about that? Well, if the largest part of the organization is these call center agents, let's say I only have 30,000 employees in the first place, and the very bulk of them I'm already retrieving in the very first step up here. Well, maybe what if I just retrieve all the users in the first place? The overhead of retrieving, all the users versus, what is that, 85% of them is not going to be that big, right? So let's try doing that instead. Okay. And let's say I still need the manager property. And then we're going to do it for each loop. Now, we need to make a decision about, we can filter up here. So let's say we're still looking for all my call center agents. Let's call this one agent. Okay. Since we have all the users already, we can kind of just look through that entire collection.
The agents, line 1.
Sorry?
Line 1.
Oh, absolutely, thank you. So, all the users with the manager property. Okay, so if we just kind of loop through all the users and say, where the distinguished name of the user matches what we have in the manager property for that agent. No, I'm not kidding. So this is one way we could approach this. Does anyone want to tell me what's wrong with this approach?
You're pulling an awful lot of data back.
I am, but as I said before, the call center agents that I'm pulling back already account for 85% of all the users in my directory. So pulling all the users, including all of their managers and maybe some other people, is not that much, right? So absolutely true. I'm gonna pull back some results that I'm not gonna need. Yeah.
You're going to have to query all 25,000 users.
Interesting. So what's going to happen down here? The pipeline is also a loop construct, right? Once you feed that all users collection containing all 30,000 users, we're going to have to inspect them one by one, 30,000 times 30,000 times, right? Okay. So yeah, I would definitely not recommend doing anything like this. Okay, what can we do instead? Well, there's a wonderful type literal built into PowerShell called the hash table. I hope everyone is familiar with the hash table. So it's a kind of a dictionary on steroids. You give it a key, it can be any kind of object, and then you kind of link that key with a value. And we can use this because all of these relationships, kind of the manager attribute, are all linked by the same property, the distinguished name of the object in the directory. So what we can do instead is we can create a lookup table of every single employee by their distinguished name in the directory. So easy track to kind of create a lookup table from a collection of information. Take your collection, pipe it to for each object, instantiate an empty hash table in the begin block, use the process block to distinguished name to assign the corresponding object, in this case by its distinguished name, and then finally return this temporary table we created. So if I run this now, I'm going to do a single query for all the users. That means I only queried the domain controller once, right? It's going to take some time, and we're kind of putting it a little bit on overwork. And then I create this hash table where every single user is contained and indexed by their distinguished name. As you see, it already returned, right? OK, so now we're done. We've got all the data we need, and we actually have it in a format where we can use it. This one down here, again, it's going to take ages because it's basically going to do 25,000 lookups or 30,000 lookups every single time. Now what we can do instead is that if we see that the agent has a manager, we can simply look it up. So we say agent, and again, the manager attribute directly corresponds to the distinguished name of that object it's linked back to, right? So now I can do this. Assign that to my object.
You need to change the $_ to agent.
Absolutely true. Up here. So what we end up with here is that there's kind of an upfront cost, right? We need to retrieve all the data from the domain controller. It's going to take a few seconds. And then, interesting, why don't we have any output?
Well, I've just created the objects.
This you haven't thrown it out.
No, I'm not assigning it to anything. It should still emit this object here, right? Oh, right. I forgot the title attribute. There we go. And here we go. That took 5-10 seconds. And now I can do every bit of processing client-side without waiting for additional lookups against the domain controller, right? If you go home today and you figure, I want to try some of this out, please try to go through your scripts and see if you're trying to kind of repeat yourself, either fetching the same data or comparing the same data again. I will tell you that in probably 70% of every single case I've looked at where people have complained about this kind of performance annoyance, this one solved it. And we're talking improvements of maybe 30 minutes to 10 seconds of processing time, right? That's pretty significant. Not just in terms of, as I said, if you need to redo this, maybe you don't need to run this sort of report every day. But there might be processes like syncing data or syncing users between different systems that you need to kind of do maybe every 15, every 20 minutes or every hour. This is definitely going to help you out. All right. Let's see if we can get back to this. Is this working? Oh yeah, I also forgot the addition operator. This should be known to most by this point. Every time you use the addition operator plus equals against a collection, it'll work, right? It'll add something to the collection. But what happens underneath is that it needs to resize the underlying array, and that's also going to take a lot of time in the runtime.
Was that the reason you set the hash table up the way you did rather than doing the hash table.add?
No, so the .add method on the dictionary interface does not exhibit this. What I'm talking about is...
When you do the array.
Yeah, exactly. So basically what we could have done, right, let's say we needed, for further processing, kind of a common enter pattern. It's this, objects, empty collection, and then people do this, right? And this one is going to be so slow. Because again, the runtime needs to kind of transparently to you resize the underlying array because arrays are immutable, right? It needs to create a new one and copy all the data over. If you do this 30,000 times, it's going to take some time.
The question is in line 3. You set up
Yes.
$table equals hash table, right?
Yes.
You've got minus begin. You've got table equals hash table,
Yes.
right? Empty hash table. You
So-
build it and then you throw it into lookup table.
Yes, correct.
Why didn't you just start with lookup table?
So I could do that, but then I had
Half the memory.
right. So basically, what I would need to do is I would have 2 separate statements, and I
No,
just
that was the
Right,
question.
right.
Was there an advantage?
I haven't observed. I haven't observed any. Again, I think it's worth noting here that hash tables, just as arrays, store objects by reference, right? So what happens when I do table underscore distinguished name equal and then assign whatever item we have from all users? I'm not creating a copy of the item from all users. I'm copying a reference into the hash table, right? And a reference is, fairly small. And so, no, we're talking, maybe an integer array of a few thousands. It's not something you're going to see. I'm not creating a copy of the entire data structure. Right. Let's take this back. As I said before, and as I kind of showed here, there are a bunch of underutilized relationships in Active Directory. Link value attributes are stored separate from the data in the Active Directory. So basically, at the very lowest level, Active Directory is just a big table of objects, right, and their attribute values. There's one type of attribute value that is stored separately from all other data, and that's what we call link value attributes. So stuff like the membership of an Active Directory security group, for example, or the relationship between a manager and his direct reports. This is stored as something called a link value. And the reason this is stored separately from everything else is that when I update, let's say, a group membership, and the group has 2,000 members already, and I remove one of them, in order to avoid what we call a replication storm, basically that each domain controller needs to replicate this huge list of 2,000 users, it can just kind of replicate the addition or the removal of one line in a multi-value attribute. So what I showed before is kind of manually linking these up back together with a manager kind of direct report relationship. But LDAP, or Microsoft's implementation of LDAP at least, also supports something called an in-chain rule. And let's see if we can find this here. Yeah, that's fine. So this query that we do up here with getIDuser -filter, that allows us to use -like, -eq, this kind of PowerShell-like syntax or PowerShell-like syntax, all gets turned in to an LDAP filter. So basically, when you write something like this, getIDuser name like John. What this is translated to internally is the equivalent of an LDAP filter, an LDAP query selector, basically. If you work, like me, for example, doing a lot of auditing or reporting of large data sets in Active Directory, where you need to be able to show or use these kind of linked relationships between objects, what you might want to look into is, let's see if I can find it here, this in-chain rule right here. A lot of people hate LDAP for its syntax. Basically, it looks a little bit like Lisp. You need to nest all of your clauses. So if I want to look for someone who has the partial name John, the telephone number 123, or the telephone number. Six. Then I end up with a query filter that looks like this. This is pretty off-putting to most people who are not into Scala or Lisp, maybe, or Scheme or Lisp. But I really encourage everyone to try to kind of at least be able to read this if you use Active Directory more often than not. The reason for this is that so we could kind of figure out in the example before that, okay, this was kind of inefficient. We did all of these queries, right? As you said before, how do we figure out whether we're doing this out of incompetence, or maybe the domain controller could help us do this a little faster? So this is the registry in my domain controller. The NTDS, that's the Active Directory Domain Services service that actually kind of runs your directory service agent and a bunch of other sub-applications in Active Directory. There's a sub-key in here called Diagnostics. And it has a bunch of keys. It has a numerical value that we can set to somewhere in between 0 and 7. And all of these correspond to different layers or different features inside the directory service agent. What we're interested in here, in terms of trying to optimize our LDAP queries, is this one, 15 field engineering. Now, this sounds like something you maybe shouldn't touch. It's actually devised for actual, field engineers from Microsoft coming out to kind of troubleshoot systems. But if you find that your domain controller is sluggish, or your application owners, say that everything is terrible and their queries never end, maybe you want to take a look at this. It's very logging intensive, so don't turn this on and forget about it. Make sure you turn it off again. It doesn't require any restart of the domain controller or the NTDS service. So if we do 15 field engineering, set it to a value of 5. And in the interest of time, I'm just going to skip ahead and turn on debug logging for this diagnostic category called internal processing. Don't set that to 5. It's going to spam your event log. And there's one more thing we need to do. See these two keys down here, expensive search results threshold and inefficient search result threshold. These basically mark some thresholds for when the directory service considers doing debug logging or extensive logging. So if you issue a query and it takes so and so long, it'll say, oh, I probably should output some debug information about this. So we're going to set those to expensive search results threshold. We're going to set it to 100 milliseconds. We're going to do the same for inefficient search result threshold. And basically what we're going to do now is we're going to go back and we're just going to do one of these terrible queries against Active Directory. Now, hopefully, we should see that a certain event is going to get logged into the directory service log. That's the Active Directory Domain Services specific application log. These field engineering events pertaining to the performance and index choices of Active Directory or LDAP queries is always going to have the ID 1644. So if we query for this, should be done in about a second. If we query for this now, I've kind of formatted it a little bit here. What we're going to see here is that it logged an event that contains all the information we need to be able to figure out what actually went down. I'm very sorry. I'm just being told that I'm out of time. I'm happy to explain this to anyone who comes and asks questions afterwards, but I'm afraid we're going to have to cut it off now. Any questions? Yep.
around in the evening?
I am around in the evening. And I'm always up for talking performance Active Directory and PowerShell.
Cool, thank you.
Do you want to